The next type of boundary is called a convergent boundary. And instead of in the divergence where we have plates spreading apart, we now have plates coming together. So we want to start by showing our plate movement. This oceanic crust will move towards this continental crust. Now if you remember, when oceanic crust and continental crust meet, oceanic crust will subduct here. And the reason we have subduction is because oceanic crust is more dense than continental crust. So it will sink down below this continental crust. Because this is happening, right in this location, you will have an ocean trench forming. Now, as this sinks down, eventually, it will get really warm and start to melt. And when rock melts, we create magma. So we'll start to get magma chambers here forming. And this magma is less dense than the rock around it, so it will rise up to the top. Now, forming on the continental crust here, because we do have these two plates moving together, we are going to see that tiny little mountain ranges can form. And anytime you have mountain ranges that have a magma source, that turns those mountains into volcanoes. So only if you have the magma source like we do here will you have a volcano present. Now, since this crust is subducting or sinking down below the continental crust, you will start to see earthquakes forming right here where these two plates are meeting. Okay, so these little dots are going to represent that. So these dots represent earthquakes. We see these forming here, and that is something that we see happening as that dives down. So we're going to get earthquakes again. We can get shallow to deep earthquakes. We can get volcanoes. Our lithosphere is destroyed because you can see the magma chamber melting and forming there. And we could potentially have a mountain range form due to the convergence or the coming together of both these plates. So actually a great example of this is the Washington-Oregon coast. If we look right here, we can see the convergent plate boundary, if we look down here, of the North American plate and the Juan de Fuca plate. The Juan de Fuca plate is subducting under the overriding plate of North America. So this oceanic crust subducts down, and potentially we can get some volcanoes here. So great example would be Mount St. Helens, a volcanic mountain on the Washington coast where this would form. So we're going to write here the Washington, Oregon coast. Now, what if I have two pieces of oceanic crust coming together? Well, they're still going to converge or come together. We do find subduction happening. Anytime we have subduction, we can get earthquakes. We can get the crust melting to form magma, so that's why you see here a volcano. But you'll notice this isn't really considered a mountain like it was up here. It's now considered a volcanic island. So it's pushed up high enough above sea level where we now can see this little island above there. And we're still going to have our ocean trench where subduction happened. Great example of this is Japan. Japan is formed in this way. Also the Aleutian Islands off the coast of Alaska. So if we look at our reference table here, here's your convergent boundary. All of these islands were formed in this way, as well as Japan over here. All convergent boundaries where subduction is taking place. So we get earthquakes, possible volcanoes, we get a trench, we get island chains possibly, like those Aleutian Islands, and lithosphere is destroyed, which you can see happening up here with the magma chamber. Our final convergent boundary is we can have convergence between two pieces of continental crust. Now anytime you have two pieces of really thick continental crust coming together, we're going to see very large mountain ranges forming. So we have this continental crust moving together. Now this will not produce volcanoes because in order to have volcanoes, we need a magma source. And you don't see any subduction happening in this picture like in the others, so we're not going to have that here. So plates come together. Right here where they meet, we're going to have some pretty big earthquakes typically forming, okay, because this crust is moving past one another. And you'll start to see some folding of the rocks, okay, because you got a lot of heat and pressure going on as these two plates, really big plates, collide, okay. We just want to write a note, this is too thick for volcanoes. So that's why sometimes you have volcanoes and sometimes you just have mountain ranges. Great example of this is the Himalaya mountain range. The Himalayas formed a long time ago when India crashed into the Eurasian plate here. So right here is the Himalaya mountain range due to this convergent boundary of two pieces of continental crust. So again, no subduction takes place, no magma, so we don't have volcanoes. So we're going to have earthquakes, and we're going to have rock deformation, which means that rock is going to get deformed. So we're going to have folds where rock is bent, and we're also going to have faults where rock is going to break. So the big difference between a fold and a fault is, did the rock bend or did the rock break? And when it breaks, that's when you can see those earthquakes forming. Our final boundary is a transform plate boundary, and this isn't moving apart or moving together, it's moving side by side. So a great example of this, which we're going to talk about more in class, is the San Andreas Fault Zone. And that is out in California. So if we look at our reference table here, it is labeled San Andreas Fault. You can see the transform plate boundary here. Transform means that one is sliding past the other. So this is the North American plate sliding past the Pacific plate. And you'll notice that California is kind of cut through that, kind of cuts right in this area here. Okay, so if you've ever heard of maybe California one day might not be a part of the United States anymore, or if you've seen the movie San Andreas, they kind of depicted that at the end. But definitely not going to happen anytime soon. Now, there's no volcanoes here. Again, there is no magma source, so we're not going to have any volcanoes. Our effects here are obviously going to be faulting, which remember is the rocks breaking apart, and that's due to the side-by-side sliding, so that you can get fractures in the rock itself. And then, of course, very common out in California, you're going to get earthquakes, and there's intense earthquakes that happen along the San Andreas Fault. Okay, so in review today, remember that the convection currents are what is moving these plates around. That's happening in the xenosphere. Our lithosphere is either going to move in a divergent way, which is splitting apart, convergent, which is coming together, or transform, which is a side-by-side motion.